Well, while we wait just a little bit more for anyone who's going to join late, uh, we I'll just mention that we'll be discussing some tools on Chameleon that are helpful for setting up your experiments and kind of orchestrating and automating them with the some of the Python library that Chameleon offers, as well as we'll talk a little bit about the CLI that you can use for orchestration, and also we'll mention the complex appliances that you can create on Chameleon and how the use of OpenStack heat templates are used for that on the testbed. We'll be going into a little bit of a discussion on each of these things as we go through the tutorial. But to get started, I'll just introduce myself. My name is Mark Richardson. I am a technical project manager for the Chameleon testbed and a couple of other projects that Kehi, the PI of Chameleon, overseas. So a little bit new to the team, and today is my first day running through a tutorial. So I fortunately am joined by my colleague, Mark Powers, who is one of the software engineers who helps operate the testbed. And he is a very knowledgeable resource as well. So if there are questions that come up throughout, I will do my best to help answer them. And Mark is here as well to answer any specific questions. We clearly only have one person here today. So hello, Massimo. Thank you for joining us. Oh, we got one more person. Wonderful. So now we got two people. We're ready to go. Thank you for joining. And we're going to go through the tutorial today. Feel free to jump in and ask questions. I am more than happy to kind of interrupt my tutorial to talk with you both more through anything you have specific questions about. But otherwise, we'll get started and we'll jump in here. So the previous tutorial that I gave earlier today, we basically went through a very basic workflow on Chameleon, and we covered the really bare essentials of accessing the testbed resources, particularly how to do that through the graphical user interface on Chameleon. And we basically just showed, how you can go from getting access to the testbed as a user to actually launching an instance on a bare metal node, and then SSH connecting to that node through SSH and actually running workloads on the node itself. And today, in this part of the tutorial, we're going to be going through some more tools to do that in an easier fashion, in a way that's easier to save, the state of your work and go back to it and replicate things. And also, help automate some of the processes involved with using Chameleon. So there's three kind of main interfaces on Chameleon for experimentation. The first one, as I mentioned, is what we talked about in the previous tutorial. That's just kind of going through the web portal interface, and that is, of course, just the usual chameleoncloud.org, and then going through to these sites. Oops, went to Chameleon, and this is one way that we can interact with Chameleon. The way that we'll be going over in the first part of the tutorial is the Jupyter interface. This is another interface for experimentation and offers a lot more features than what you can get through the graphical user interface. This is also going to be a lot more efficient if you are doing something more complex, and it's also just easier to package up your experiments as artifacts through the Jupyter interface. So we'll walk through a lot of the features that we have available there. And then also we'll go through the command line and talk a little bit about how the command line works, what exactly you can do with it, and we'll show a little bit of the commands, some of the essential commands that you can use for the command line. And part of that will kind of feed into the discussion a little bit about the heat templates and how you can get access to those resources. So Jupyter is essentially a kind of environment that you can work on. Probably you're already familiar with Jupyter. It's a pretty common tool and nowadays, and it's also one of the reasons that we decided to use it as a integration with the testbed, because it's fairly popular and well kind of documented and understood. And it also allows us to kind of combine both literate programming with actual telling of a story or presenting results, explaining how to run an experiment. So the Jupyter Notebook environment in particular is nice for creating artifacts. And it's quite useful because all of this is integrated with Chameleon. So when you're working on the Jupyter interface and I'll go through how to get that in a second. But you'll actually already be authenticated to the testbed. Everything will already be kind of set up for you so that you don't have to worry about, connecting these services. It's already set up and allows you to just focus on working on your experiment or developing your experiment. So one of the main tools that you may use when you're working in the Jupyter environment is something that we call Python Chi. This is a Python library that we, the staff, the operators of Chameleon, have developed themselves, and it's available for you to install using common tools like pip. There's some detailed documentation about how to use this Python module, and we also provide tips and tricks about how to handle errors. Some of the more advanced operations like creating networks and orchestrating experiments across multiple nodes. But again, this is a pretty handy tool, and we'll be going through a couple basic functions that you can use this for as well. And so, yeah, actually, let's go ahead and do that now. So I'm going to click onto this tab. Actually, first, let me go to the main website. So if you are coming to Chameleon for the first time, which I don't think may be the case for the folks here today, but you'll have to, of course, create an account, and you'll have to be added to a project that has an active allocation. As with pretty much everything on Chameleon, this is an essential step before you'll be able to actually use this in any meaningful way. So again, make sure that you have a project and that you have your account set up before you try to access the Jupyter interface. But the way that you'll get access to it is through the experiment tab. In the last tutorial, we went through how you can access the sites through this tab as well. And that will bring you, of course, to these different dashboards here that will, then you can make reservations, etc. But instead, we'll be going to the Jupyter interface, and that's going to launch this Jupyter Lab tab here. And this is going to basically load a workspace that's associated with my user ID. And as you see, once that actually loads, I'm just going to skip ahead here, then you'll actually see, I can see the workspace that I'm in, and I can see some of the files that I have from some of my previous work on this interface. And as you can see, this is basically just the same, vanilla Jupyter Lab interface that you're used to if you have used Jupyter before. We have a welcome notebook here. That's just like a very short kind of documentation of places to get started. And we'll actually be working through one of these tutorials today as well, this bare metal experiment pattern, which will help kind of demonstrate some of the features with Jupyter and Python Chi that make it useful for research and for education on the testbed. We also offer a couple of other tutorials. I'll actually just mention those now. We'll talk about Trovy a little bit later, but all these tutorials, all these artifacts are available as well on the testbed, and you can find a lot of these on our Trovy repository. But again, these are really useful for getting started, and sometimes you can even take them and just repurpose them for your own research. So we'll go over how to do that a little bit as well. But to get started, let's just create a new folder here. So I'm gonna make a new folder and just say my Python Chi tutorial. And the reason I'm going to create a new directory is because at the end, I'm going to show you how you can actually save this artifact and share it with other folks on the testbed. And, when you're creating a new kind of artifact like that, it's useful to start a new directory. Again, just also showing that this is pretty much standard Jupyter. I can make new files and upload stuff from my local computer, etc. And there's a lot of different, functionality already built into this. But I just want to demonstrate some of the Python Chi features that will kind of further highlight in the notebook that we'll go through, the example notebook that we'll go through later. But I'm just going to create a quick notebook from scratch here. And just to give you a sense of how this Jupyter, integration is really kind of useful with the testbed. So, I just launched this notebook from scratch. I haven't, really done anything other than just launching the Jupyter Lab from Chameleon. So the cool thing is that once I actually start an environment in here, I already have a lot of libraries that are already imported in here. So for instance, if I wanted to use the popular pandas library for data analysis, I can already just import that immediately. I don't need to go and install it with pip or anything. You can see the kernel that we have already here running. And, of course, there may be examples where like you want to customize the environment a little bit more. Another cool feature with the Jupyter Lab is that you can also launch a terminal, and this will actually allow you to just interact with the environment in the same way you would from like the command line. So I can go in here and have my terminal and also, kind of do things on here. So if I need to install, for instance, an additional library, let's say I want to install Altair because I want to use that for some visualization, then I can just go into the terminal and I can just run this installation command. And after that's finished running, I can then just import that into my notebook like I did with the pandas library. And that will just, work. So there's a lot of flexibility here as well. You can kind of set your environment for your experiment or stage it as you need to. And, if you need the extra customization, there is, we provide the access for that as well. So it's just kind of a nice aspect of having the Jupyter Lab environment. Now, as I mentioned, I wanted to show a couple of things related to the Python Chi library. So this is a Python module, so you can import it in the same way that you would import any other Python module. Again, this is also something that we've already pre-configured in the environment here, so it's immediately accessible. There's no additional installation steps once you've kind of logged in and authenticated to the testbed. And so I can just import the library immediately and start using it for my work. So just to show you a little bit of kind of the important first steps that you're going to want to take when using this module is you are going to have to kind of specify which site you want to use. It's not going to be automatically configured necessarily. So one of the first kind of commands you're going to run is this use site command, use site method, which is going to be basically just a way for you to tell the module, like, I'm using this specific site. So if I'm creating a lease or I'm looking at launching an instance, the library is going to know specifically which site to go to in order to do that. And if I just run command enter on this and run this code, it should give me this little info at the bottom if everything worked correctly, and it will tell me that I have successfully switched to this site. It tells me which URL, which is just the graphical user interface that we're all familiar with, and then it will give me some additional information for the site. So that's one of the kind of first things that we're going to run. The other thing that we'll also want to do before we start doing anything with this library is we're going to also want to set which project we are using. So again, as I mentioned, everything on Python or on Chameleon requires having the active project. So if I go to here, I'm just going to double check that I'm using the right project that I've already set up. So it's this 241306. And I'm going to put that project number in here. And that's going to be the active project that I'm using in the notebook. And just to confirm that that gets set correctly, we'll add this print statement, and I'll just say sorry, gotta get a couple of these typos out of here. And if I run this, then I'll see that I've set the project. And now if I run this method git, I'll see that I'm using this project specifically as the active project. So this is just important to kind of set the context for the library before you start using it to do anything, just to make sure that you have the appropriate things set up, you're using the right project, etc. So now that we've kind of gone through some of these basic, just, setup processes, once you've gotten the site and the project set, you can actually start doing cooler things like, for instance, getting leases that you already have associated with your project, which we'll do first because I have a lease that I've already created from the last tutorial. And then I'll kind of show you quickly how we can also create leases using this tool and even launch instances once we've created the lease. So there's a couple of different kind of libraries in Python, or sections of Python-chi that you can use. So one of the most important ones is a module called lease, or an object called lease. And this is basically what you're going to be using to do anything related to reservations on Chameleon through this library. So I can say import lease from chi, and if I wanted to, I know, for instance, that I already have a lease running on Chameleon. So I can just say, I want to see what that lease is, and I have to know what the name of the lease is. So fortunately, my lease name is very simple and I can remember it easily. But if I run this code, then once it returns, it's going to basically have a lease object, which is essentially just a dictionary with a bunch of data. And but the important thing to see here is that this is actual data about the lease that I have running for this project on the testbed. So if I go to leases here, I can see I have this lease, my first lease. And here, after running this method get lease, I receive an object that has all this information, so I can easily get all of this kind of context into this environment just by using this one method and having the lease reference to look up. And as you can see, there's a lot of information in here, including reservations that I have for the lease. So I can actually see which reservations are associated with the lease, and I can look those up using this library as well. So for instance, there is another important component to this, which is the server. And when I import that from the library, I can do things like, for instance, look up all the servers that I have running, again, associated with the project that I've set up here. And I can see that I do actually have an instance running. This is an instance that's running underneath this reservation that I set up previously. And I can also kind of look up servers through the library as well by looking up the name of it. And then these objects also have properties associated with them. So for instance, if I wanted to see what the status of my first instance is, I can add this little status tag at the end of that, and it will tell me that this is running. So for instance, this could be useful if you're writing some kind of script that you want to have, you need to wait, or, you're kind of monitoring the status of the server. So just kind of another example of, showing you how these tools can be really nifty in terms of actually structuring and orchestrating your experiments. The other thing you can do is you can also delete things. So I'll just show you quickly server delete server, and then I can do another method to get the server ID, which is what I need to give this method or this function in order to delete the server. And oops, it's copying the wrong code. So then I can run this method, and I can delete the server, and it will just kind of return this empty list. But if I go back here to my instances, then I'll see that the instance is getting deleted. So not necessarily something that's like the most important thing that you could do with this, but just to kind of show you that this really does give you quite a lot of control over what you can do with the testbed, and how you can kind of get access to different components of your experiment. So the last thing we'll go through here before moving on to the more exciting example of the bare metal experiment pattern is just how to create a lease. So again, just kind of showing how this library kind of connects to the testbed and allows you to do things that you may normally end up doing through the graphical user interface. So in this next example, I'm going to create a new lease, and I'm going to give this lease a name, and it's going to be my second lease. I'm going to create an empty list of reservations. So this is where I'm going to basically tell the system what kind of node I want to have, and if I want to have a floating IP address, and so on and so forth. I'm going to put all that stuff in this reservations list. When I actually create my lease, I'll pass that to the function, the method that does that, and that will actually create the lease. And then the other thing I'm going to specify here is the lease duration. So I want a lease that's only 1 day. And then I'm just going to print those variables down here so that you can see what you get. So this is a special method that the Python Chi library has that just gives you the start and end date that you want to put for your lease based on days. You can also specify how many hours you want. So if I wanted to do like 12 hours, I can also specify that in here. But we'll just do 1 day. And the next thing I'm going to do is, as I mentioned, I needed to add the information for the reservations that I want to create under the lease. So I'm going to do that with this code here, and I'm going to use this function add node reservation. I'm going to give it the list that I created up here. I want to tell it how many reservations I want. So I just want 1 node. I'm going to say just count 1. And then I'm going to say compute Skylake. And actually, I may change this because I think compute Skylake is being used. So clearly not everything available through Python Chi. You may still need to go back to the graphical user interface, but yeah, so I can see we're going to use this one instead. So I'll tell it this is the node type that I want to reserve. And this method is just going to modify the list in place and just put all the information in the list that I need to include when I submit my request for the lease. So here it's going to show I'm requesting a physical host. These are the properties that I'm going to use to filter for which hosts I want. And then this is the count. So how many hosts I want to reserve. And then I can actually create the lease using the create lease method, which again is comes off of this lease module here. And for that, I'm going to provide the lease name. I'm going to provide the reservations, which I've now populated with actual specific information. And then I'm going to provide the end and the start date for the lease. And I'll run, oops, I think I need to. So now I just submitted the lease, and it's going to basically pass that request along and just return kind of this lease object that it created. But this is not actually an active lease. As you can see here, this is still pending. So I haven't actually, this isn't actually something that I can use to interact with the testbed. It's just kind of giving me the information. And right now this lease is still pending. So if I want to see, is this lease ready yet? Is it ready to use? Which it should be because I launched it to start immediately. We can use this get lease, and then I can put in the ID. And now I can see that the lease is actually active. So now we see that the lease was successful, and I can see that I had this reservation, and I created the reservation. So now if I wanted to, I could go ahead and actually launch an instance from here. And I'm not going to launch the instance because we'll do that in the notebook that we'll go through in a second. But I can actually, reservation. But I can use the information from this object to actually create a new server instance. So the code for that is pretty straightforward as well. The kind of main essential things are you're going to want to provide an image name. You're also going to need to provide this node reservation ID. And then you'll also need to give your server a name and tell it what kind of key pair to use. some of these options are kind of defaulted. So as I mentioned, Python Chi has a lot of documentation. And for instance, there's many options that you can customize with this function, with this method. So I'm only covering a few of these options here. But as you can see, for instance, if I don't specify an image name, it will just default to a particular image. And yeah, so I'm not going to run this, but if I did run it, then basically what would happen is it would start setting up the instance, and then I would be able to access it after it started running. There's also, some utility functions attached to this library as well. So there's something called Chi image, and this has a method called list images, which will show you basically the images that are available to use for launching instances on the testbed. And this is also, I think, going to be site specific. So again, another important thing to make sure that you're setting, the site and the project when you start working with this. But, again, very useful if, you want to kind of look at stuff from the command line, or if you're working in here and you want to have some kind of logic involved with what images you're launching. There's ways to do that with this library. And there's a lot more, stuff in here that I didn't go over. So, you can also use this to launch workloads on Chi at Edge. And there's ways to build networks and attach those to your instances. And we have, different storage methods that you can use in here as well. And as we'll see in the next example, we can also use SSH tool to connect and run scripts on our instances, all from the command line, or all from the Jupyter notebook, just using this library. So that's just kind of a quick demo of this library. And finally, I'll just kind of quickly show you something cool about using the Jupyter interface, is that once I am done working on something, I can actually package it as an artifact and then share it on the Trovy site on Chameleon, which, if you have not seen before, is this repository. It's a public repository where you can upload both public artifacts and private, but other users can see these artifacts on here. And I can actually do that from here as well. So I can say, this is my test artifact, and I'm not going to put in anything here, but I could say private or public. I'm going to keep it private. And then I just need to provide some author information on here. And then say upload, and it will automatically upload this artifact to the Trovy portal. And I can click on this link here, and it will actually take me to the artifact page. So here I can see this, and I can edit it more if I need to. And this is kind of a good segue into what we'll go over next, which will be this bare metal experiment pattern, which is going to be a little bit more of a complicated example of how to use the Python Chi library and the Jupyter interface to actually create artifacts and help, structure your experiment, make it more reproducible, make it easier to share your work with other folks as well. And we'll start by going to the Trovy repository. And as I said, there's a bunch of artifacts that are linked on here. Trovy is basically a way to, share your artifacts, let other people run them. So when you upload an artifact to Trovy, you're going to be able to go to the artifact page, and you're going to see a bunch of these options on the side here. And as long as you have a Chameleon account and you have an allocation that you can use to launch the artifact, then you'll be able to click this button and it will automatically open up this Jupyter Lab interface for you. but specifically with within this workspace of this artifact. So this is not going to necessarily be the same interface that you see when you just launch Jupyter from how we launched it before. But so as you can see, I don't have these other files in here. Now I'm just seeing this one particular artifact file here. And this was not modified by me or uploaded. This was another user. So it's pretty much the same kind of environment, but instead I'm going to be, kind of in this more isolated place, and I'm going to be able to kind of interact with the files here, but in a slightly different manner. So now that we've launched the bare metal experiment pattern, I'll go ahead and click into this folder, and I'm going to see a bunch of different files here. I'm actually going to get rid of this one because I'll talk about that a little bit later. But it's going to be pretty similar to what we were looking at before with this, right? So there's going to be some notebooks and also some scripts, which, as we're going to see, these are going to be the actual experiment scripts that are run. And you'll see how you can actually do that through this interface with our Python Chi tools. And then this is going to be where, we'll put the data from the experiment. So when we launch this, we'll see that there's well, let's take a look at the README first. So the README is just going to tell us kind of, hey, this is my artifact. Here's an overview. Again, this isn't super relevant unless you're, providing this artifact for someone else to use. If you're just kind of working on your own experiment, maybe this isn't something you have, but a lot of the artifacts that people upload to Chameleon do tend to include this kind of documentation. It just makes them more useful to use. If we go to the experiment notebook, we'll see that, again, this helps illustrate the usefulness of using things like Jupyter. So here, you can actually write markdown text directly into Jupyter Notebook. And this can be really helpful because it can help you provide the documentation for someone who's trying to replicate your experiment, or you can provide notes to your colleagues as you're working on something together. So this is just really useful additional feature to have. And then, of course, mixing it with the code is really useful and helps create a powerful kind of combination. So here they're just kind of explaining that we're going to be using this particular node type. We're going to use these resources, and then we're going to have to provide some configuration. So fortunately, we already have an active project, so we can just use our own active project. We don't need to worry about using some other project here. And again, right off the bat, we're going to see that we're importing Python Chi here. We're using, we're going to use the UChicago site again. And I need to update this. And we're going to use the 306 project again. Uh, 241306. And so I'll run that code, and then here we can see what we saw before. We're using the site, and we've set the project. And then we're going to go ahead and create a reservation next. So this is going to be the same thing that I showed you in the other notebook, except in this case, we're going to also add this floating point reservation. So in the previous example, I was showing you, this is how you add the information for a node, for a host reservation. And in this case, we're also going to add a floating point reservation so that we can later SSH into the instance and run our experiment scripts. So we're going to create a lease for this particular node type. We're going to set a duration of 3 hours, and then we're going to run this create lease, and we're also going to use this environment for the lease as well. And so, or sorry, no, this is just the setting the name of the lease. So this is setting the lease name. We have the reservations, and we've got our start and end date. And then that's going to return the initial lease object. And then we'll use this special method, wait for active, which is just going to keep checking the lease ID and waiting for it to start. And it's basically just going to pause until the lease actually becomes active, and then it will run the rest of the code, which isn't doing anything except just making sure that we didn't hit any unexpected errors, or, well, actually any expected errors, as well as unexpected. And then we can see here now that the lease is active. So we'll just go and check to make sure that the lease actually shows up here. And here it is. So I can see that the lease was created successfully, and I'm ready to start using this lease for the rest of the experiment. The next thing that we're going to do is we're going to create the server. So I'm just going to run this immediately because this is going to take a little bit of time to actually complete. But once we start, what we just ran here is what I was showing you before, except that we didn't actually run it the first time. Here we're actually creating the server. And again, this method create server. We're going to tell it which server name we're using. The image is going to be the CentOS 8 stream image. And we're going to be using the reservation ID from our lease that we created just a moment ago. And then again, we're going to use this method, except this is for the instance. So it's just going to wait until the instance is ready to start running before it does anything else. So while we wait for that to happen, let me kind of take a second to breathe and take a sip of my tea, and also ask if anyone has any questions about what we've gone over so far. If there are no questions, then I'm going to go ahead and talk a little bit about the command line interface. So we've been talking about Python Chi so far, and using the methods and the library to kind of automate certain things and do things programmatically on the testbed. Another way to do this, as I mentioned on the slides, is through the CLI. So there is a CLI interface that you can use to orchestrate. I would say that the CLI is in some ways a lot more kind of useful than the Python Chi library, but it's kind of, the trade-off between how complex and low level do you want to get with the testbed versus using something that's a little bit more high level and easier to understand. So OpenStack CLI is what the Chameleon testbed kind of exposes to users to use as a CLI tool. And we're going to kind of go through quickly how to do that, just to get you familiar with, if you're interested in using it in more in depth, you'll at least have kind of an idea of how to start working with it. So as I said before, we have this terminal that we can open up in our in the workspace that we're in, and this allows us to just kind of interact with the environment through the command line. The CLI that we'll be using is going to be this OpenStack command. So this is going to be already kind of pre-configured and pre-loaded into the environment for you without you having to actually set anything up with it. However, because OpenStack is going to be kind of tied to site and project, as with everything else, you're going to have to probably configure the OpenStack client so that it's using the right project. And just to give you a sense of how that works, so for instance, if I do OpenStack project lists, so this is just a command that shows me which projects I have associated with my user account on Chameleon. I'm going to be able to see all the projects that I actually have on Chameleon. However, if I do something like, for instance, OpenStack reservation lease list, so this is a command for, let me zoom in a little bit, sorry. This is a command for just listing active leases that I have. When I run this command, as you'll see, it's going to give me kind of a weird output. And once it actually runs, let's see. Yeah, so here it's telling me like, oh, I have this in-pitch development lease, which is not actually something that I am using, right? If I go back to my lease, I don't see any of these leases. So what's going on with that? The reason that that's happening is because I need to configure OpenStack to use the right kind of credentials in order for me to see the project information that I'm interested in. The way to use this is to use the OpenStack RC file, which is going to be downloadable, and you can actually just download it from the Chameleon graphical user interface. So, and this is going to be, again, specific to your project. So if you make sure that you're on the project that you want to use it for, but you're going to go to the dashboard here, and then I'm going to click on my login drop down over here, and I'm going to select this option that says OpenStack RC file. And then this is going to automatically download this configuration file, which if I open quickly, I'll just show it on the screen. It's going to have this, all these, basically these variables that it's going to set with all of my credentials for my own account. And what I can do is I can actually just upload this file directly. So I have the file that I just downloaded. I'm going to open it here. And then I'm going to run this OpenStack source, or no, sorry, I'm going to run source. Source, and then I'm going to run the this particular file, and then it's going to prompt me for a Chameleon CLI password. It's pretty easy to set this up. You can actually set this up pretty quickly, and I think there's some documentation which I'll try to pass on in the files that I share after. But you will have to kind of put this password in, and in order to actually authenticate. But after you put the password in, then now I will be able to still run the same commands here. But instead of seeing kind of like this default project that I got defaulted into, I'll be able to actually use the project that I'm interested in using. And so now when this returns, it will actually show me all the leases that I have running on my, for this particular project, rather than this other list that it generated at first. So once you have that set up, then OpenStack is a pretty powerful tool to use for all kinds of things on the testbed. Let's go back. Looks like our server is still waiting to run. So there's a couple different ways to interact with OpenStack on the command line. You can either run it like I was running initially with like the OpenStack command and then additional commands after that. Or if you just run OpenStack by itself, you'll enter an interactive shell, and then you can just run commands from the shell without having to put OpenStack at the very beginning. I think this is also a little bit faster, so it makes for a little bit of a nicer user experience. But again, there's a lot that gets exposed through this. So for instance, if I wanted to see the hosts that are available on the OpenStack site that I'm using, then I can use this reservation host list command, and I'll see a list of the host names and IDs and etc. I think there's also a way to look at, for instance, the actual information of a host. Actually haven't tried this before, so I'm not sure if this works, but there's ways to, for instance, look up and actually see the specific information about each host. Oh yeah, so that works. So here I can see, this is a GPU, and I can see information about, manufacturer, et cetera, CPU architecture. That's kind of the powerful aspect about OpenStack, is that it just gives you really low level access to a lot of this stuff. So, kind of using the command line in combination with the Python Chi library and the notebooks and the Jupyter, there's a lot of really fascinating stuff that you can start to do, and you can really start to, work on some really complicated things on the testbed. So our server is still waiting to start. It's taking quite a while, but in the meantime, speaking of doing more complicated things on the testbed, I'll go through and mention heat templates while we're still waiting for at least the server to start here. But heat templates are another orchestration tool for that's provided by OpenStack, and this is a open source platform that so OpenStack Heat is an OpenStack tool. OpenStack, as we all know, is what is kind of underlying some of the Chameleon features. But it's a way to define and automate the deployment of complex cloud environments using these human readable text files that are called heat templates. And heat templates are written in YAML format. They describe the desired state of your cloud infrastructure. You can use them to specify resources you want to create, instances, network, storage, and then you can configure all of those resources and define their relationships. And this is often kind of referred to as an infrastructure as code approach. So heat templates are kind of, we actually provide a way to use these templates on the testbed as well. So if you go to orchestration and you go to this tab called stacks, this is where you can actually define stacks and use templates to create stacks. So in the template, when you're adding it, you can have different sources, files. You can also just directly put template data in. And you can also use a URL as well to import a template. And then you can also select an environment source. No, I can't do that. So this is one way to create the stacks on the testbed. And I believe when you launch the stack, I can't really do this here because I don't have a template to put in here, but there is a point where you tell it basically, I want you to use this reservation. So that's how you associate the stack back to the reservations for the resources you're using. The other cool thing with the heat templates are, because this is based on the OpenStack infrastructure, a lot of things are already kind of built in and integrated. So for instance, on the, where was I? Stack page here, if I go to, template generator, so there's ways to kind of explore different templates. We also provide some templates here, and then you can also just browse through the resources that are available. And so you can see there's, a lot of other OpenStack services here, Blazar, Glance, Manila for the network, and Neutron. And then we have we also have, Swift down here. So there's, just a huge amount of resources that you can access through these templates. And just to give you an example of the templates that we have available. So if you go to appliances, if you remember in the first tutorial, we talked about this mostly in the context of images that you can use to source an instance, but we also do have heat templates available on here. So for instance, if you see this little badge here that has like this little icon, this signifies heat template. And if I click on here, this is a template for deploying an Ansible cluster. And I can actually, I think I can download. So I can see the template here and how it's basically setting up the cluster. And as you can see, this is can get pretty complicated, and there's a lot of specific kind of jargon and parameters that you're going to have to kind of set up for these things. But we do offer documentation on some of this. And again, this is an OpenStack thing. So there's, of course, documentation available from other places as well. The documentation on this is going to be mostly under this complex appliances tab on our read the docs. We also have like an example that you can work through to kind of get a sense of how these templates work, and kind of explore the power of those. So finally, we have gotten our server to start. This took a while. I think this image is a pretty large one. So, but we've gotten a confirmation that our server is now done. This next step, we're just going to quickly associate our floating IP address with our server. So again, this is another useful way using Python Chi that you can just kind of automatically do these things. And then we're going to just test the connection to make sure that we can connect to the instance with our floating IP address. And then the rest of this example, which we'll go through a little bit more quickly because we're kind of hitting the end of our time here. But once we kind of establish the connection to our instance, kind of similar to what we were doing when we just SSH into the instance, we're going to take these scripts, and the first one, this one, setup.sh, is just going to install the packages that we need to use for our experiment. And if you see this little note here, I wouldn't have to do this if I used the saved disk image. Again, this is referring to the fact that you can take snapshots of your images with Chameleon. So there's a Chameleon snapshot tool that you can access on the testbed, and that's a really easy way to basically create images. So if you have a lot of packages that you commonly use for your experiments, you can probably just create an appliance that already has all of that and just continue to reuse that for all of your work on Chameleon. but anyways, this is setting it up, and then we have our experiment script, and this is going to be actually running the experiment, which is a power consumption experiment where we're basically just going to be looking at how much power the node is using when it's running at different kind of workload capacities. So 25, 50, and 100%. And we're still waiting for our connection to be confirmed here. But once that is confirmed, then we will be able to start actually running these scripts, and we'll be able to kind of see the output, and that will kind of be the conclusion of this tutorial today. So while we wait for the connection to get confirmed, I'll mention some more experimental practices and kind of tips. So reservations, as I mentioned in the first tutorial, these are limited in length. If you're going to use reservations, you'll need to make sure that you have sufficient time in advance to look at if you have certain popular high demand resources you want to use. It's really important to kind of do that in advance. CC snapshot, again, that's a command line tool that you're going to be able to use to snapshot your images. This is really important. The reason why I mentioned that reservations are limited in length is because a lot of times what happens is people are using their node, and then someone else takes the node for a little bit of time after they're done, and they are like, oh no, what do I do? I'm going to lose all my work. This is really important for you to back up your work, upload your data to the object store. So for instance, we have, where am I? We have object stores that you can create and associate with your instances. There's also a shared file system that's good for using for data. That one's particularly useful because you can also let other people access it, or so other nodes can access it. So you can have, a single shared file system across multiple instances. And it's really important to kind of be, making sure you use data backups and things like that, because once the lease finishes, everything gets wiped off the node. So if you just have your data saved locally, it's going to be gone. It's possible for us to kind of restore it, but it's not something that we like to have to do, and it's better for you to just make sure you're storing your data and backing it up as needed. And then of course we also have a lot of helpful resources that we offer for more questions. So let's see, did this work yet? It's still not connecting. Well, let's see if we can get it to connect.
I can take a look. There may be an issue with that particular instance, but
Does anyone have any questions in the meantime? Very close to kind of finishing this example, just be running through kind of showing you how the results can get kind of transferred back to this environment, and then we'll be using this notebook here just to show you that you can then present the results. So again, this is why it's really useful to use the Jupyter interface with these different environments and interfaces, because you're kind of going immediately from reserving the resources, running the experiment, to getting the results, and then actually presenting them, and doing that all in one place, where so that someone like me can come along a year later, run the same thing almost in the exact same way and get the same results. So this is, again, we talk about reproducibility a lot on Chameleon, and this is why, reproducibility is such an important aspect of what we do on the testbed. Because, taking something like reading a paper and hopefully democratizing it a little bit more so that no longer do I just have to look at the paper and read the figures and be satisfied, but I can even, maybe I could even load a notebook on Chameleon or whatever the test bed might be and run this stuff myself and actually generate the results myself, and then go back and, decide that I want to run it on a GPU node instead, and I want to see how that changes the results. And right, so this sparks new ideas for myself. So, man, I don't know if this is going to connect or not, but
yeah, I think there is an error with the hardware here. I'm taking a look. I see the network interface didn't configure correctly, which is why you can't SSH. So I will have someone look into this. So this is something where if you submit a help desk ticket for, as Mark was mentioning, we can investigate.
Yeah.
One of the downsides of using bare metal hardware is that you're more exposed to these hardware low-level issues. But we do wish to use the help desk, and we offer the help desk to, we try to be very supportive there on all experiments.
So, well, in that case, I'll just kind of explain. The rest of this code is going to be taking these scripts and using the SSH function to upload them to the instance and then running them on the instance. And then it's just going to be kind of downloading the data after the experiment runs. And after that is where we would present it. So that kind of concludes the main kind of example there. And as I said, I already went through some of the heat template stuff. I don't know if Mark, if you want to mention something there a little, maybe provide a little bit more context in case I something in my own assessment of it.
No, I think you covered most of it. I will say you mentioned Python Chi. So I think, as Mark mentioned, that the CLI has the full power of OpenStack. And Python Chi is something we've built on top for some of the most common operations. And we are looking into very soon adding more Chameleon workflows to it, such as Mark pointed out that the availability calendar, you still have to go to the web to see. So we're looking to integrate that into our Jupyter notebooks. So that, watch out for that upcoming. But yeah, I think overall it was a very good coverage.
Wonderful. Well, do we have any questions from the attendees? Is there anything, any clarifications, requests for additional topics? All right, well, if there are no questions, we'll go ahead and stop the tutorial here, and we will be following up with the last tutorial on Chia Edge on Thursday, and then we will have a short, well, about an hour or so of kind of open office hours a little bit after that tutorial on Thursday afternoon. So if you want to pop in and just, ask some questions, or if between now and then you do some more exploration on Chameleon and find that you have a question about something else, that's a good opportunity to come by and just kind of chat with the engineers and get some of your questions answered.